Thursday and Friday of last week, we talked about direct variation. Raise your hands if you remember the activity we did with direct variation. We had those whiteboards, we graphed them. Make sure you're not talking while I'm talking and you are paying attention. I know you're not paying attention if your book isn't open at page 83, right? Okay, so open page 83. Today we're talking about inverse, but let me remind you real quick about direct. Direct variation, when you graph it, it had to form a straight line, and it had to go through 0, 0. So those two tests, right? And a third thing that you don't want to forget, especially today, it was always multiplying. What is direct variation always doing? Multiplying. Always. Well, today's inverse variation. If direct variation is always multiplying, inverse variation, dividing. So watch for it. Now this one, I can teach you inverse variation through this example, and I think you're going to be rock stars at it. Because what this first page is saying, will you underline this? There are 9 ways to arrange 36 square blocks to form a rectangle. Put a rectangle around the word rectangle. Here are 2 ways. So the first way, put a little 1 above it, circle it. First way, you can do a height of 4, 1, 2, 3, 4 of them. Base of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. There you are. Do you believe there's 36 blocks in there? Okay, good. Okay, here's another way. You could do a 6 by 6, but wait, isn't this a square? Is a square a rectangle?
Yes.
Yeah.
No.
Counts. So we need how many total ways? I've given you 2. You need 7 more ways, but let's do one more way together. Donnie, do you have another way?
There's base 36, height 1.
Good job. Base 36. Now, I'm not going to draw all 36 blocks. You guys don't need to either. So I'm going to do this. Base 36, height 1. H1. Okay, there's 3 ways. How many total ways are there, though?
9.
There's 9. I'm going to start the timer. You're going to work as a table. Start sketching. Ready, set, go. Ask us questions. Okay, hand in the air. Give me another way we can arrange 36 blocks. Joey, tell us.
12 by 3.
12 by 3. Did you do it 12 along the bottom base? Actually, Joey, technically, I would say he gave me 2. So we could do 12 height-wise, and then 3 base-wise, right? But technically, couldn't I just switch his around and do this? And say, this 12 is now the base, and this 3 is now the height? How many of you figured out you could just flip-flop them? Thank you, Joey. All right, I need another hand in there. What else are we missing? Donnie, what's another pattern?
Height 6, base 9.
Height 6, base 9? I think that's more than 36 blocks. You've got it, though. You're so super close. I'll get a sketch going. Base 4? All right, this is kind of a bad guess. Or, excuse me, a bad sketch. We've got base 4, height 9. That would totally work. So I'm going to take Donnie's and I'm going to flip-flop it this way. We could do base 9, height 4.
That's what that.
Oh, do we already have that one up there? We do think so. We've got to come up with 2 whole new ones. Okay. All right, look at all these hands here. What do you want to do? Base 18. Oh, that's a long one. And then what's the height? Height 2. So we could do this way. Height 18. Base 2. Wait, so we're only missing 1? Which one are we? Oh, Max, which one are we missing?
8 and 4.5.
You know what? I think they're all whole numbers. We didn't use decimals on this one. I'd say we already kind of have the other half on there. Courtney, did you see it? Yeah, good one. 36 height. Base 1. Woo! How many of you got all 9? Good job. Good job. All right, let's organize our information into the table. All right, here we go. I'm going to need your help. We did 36. Base 1. Okay, so how do you figure out area? Do you remember? Times them. 36 times 1 is? 36. All right, and then I'm just going to flip-flop that. So we could have done height 1, base 36, and the area is 36. Okay, help me. What was another combination we came up with for this? What was another one, Cameron? 12 on height, 3 on base. Thanks, Cameron. Because what's 12 times 3? You noticing a pattern? All right, so flip-flop it. We could have done height 3, base 12. That's also 36. All right, another hand in the air. Help me out with this one. Jalen, what else? 4 height base 9, thank you. 4 times 9 is definitely 36. We're still using 36 blocks. So height 9, base 4, area 36. Alright, what are we missing? Alec, what else?
You can have 18 height
18 height
and 2 base.
and 2 base, thank you. That's still 36. So this one, height 2, base 18, that's still 36. Wait, we're only missing 1? What's that last one that we need? Courtney, what is it?
6 height.
Perfect. 6 height, 6 base. Can we really flip flop that one? Don't you think it'd be the exact same flip flop? All right, 36. Okay, good work, good work, good work. Now let's see if we can come up with an equation for this. So our equation has to have H in it, B in it, and A in it. So how can we come up with an equation that gets these numbers to each other? For example, how do you figure out, well, I almost gave it away. Max, can you figure out an equation for this?
I put height times H times B equals A.
H times B equals A. Does that work, guys? H times B equals A. Totally works. What if, nope, I'm gonna take it. I like that. That's very well done. Okay, one more. What if I wanted you to create a division problem? That's a multiplication problem. Can you still use H, B, and A and create a division one? Charles, tell me what you're thinking.
A divided by B equals H.
A divided by B equals H. Does this one work?
Yes.
A, 36 divided by 1. Is that 36?
Yes.
Totally. 36 divided by 36 is that one. Good work. Interesting. Okay, now we're going to the top of the next page, so stay with us. We're going to come back to this in just a second. So it's saying when the height increases, what happens to the base? So let's find a spot where the height is increasing. Oh, look, right here. From 1 to 12, is that increasing? Totally. Height's increasing, but what's happening to the bases?
Decreasing.
They're decreasing. Let's fill in our sense that. So right here, when the height increases, the base decreases. All right, next one. When the height decreases, what do you think happens to the base?
Decreases.
Okay, let's increases. So let's see. We've got to find where the height is decreasing. Let's go from 12 to 3. 12 to 3, totally decreasing. What's happening over here? Increasing. You were right. Increases. Okay, like Charles just noticed, we can write an equation where height is 36 divided by the base. Now what we talked about before, this actually is an inverse variation because it's dividing. But I scribbled over in your workbooks, I put a y there and an x there because you're usually going to see y's and x's. Remember the variable always has to be the denominator if it's inverse. Okay, let's do a quick review and make sure you know the differences. Direct variation. Hold up an arm. Always makes a straight line. Make a 0. Always goes through 0. Cross your arms. Always multiplies. 3 checks. 3 checks, right? All right, show me multiply. Show me straight line equation. Show me 0. And which one is that? Is that direct or inverse? That one's direct. Okay, ready for inverse. Inverse. Oh, it's hard to create the signs for this one. What I want you to majorly remember is 2 things. How many things? 2. First, it's always dividing. What is it? Dividing. Second, the variable always has to be in the denominator. Like this. So maybe we could do a division sign. So division sign, it's dividing. You with us, Cameron? You with us, Cooper? Always dividing. And then maybe let's point to the denominator. Or point to the denominator. Yeah. And then variable's always in the denominator. Okay, this next part, let me show you. Okay, it's not in your workbook, so you can put your pens down, pencils down. Just watch. Okay, check it. Right here. Is this showing division? What does that line mean right there?
Division.
So is it showing division? Yes, is a variable in the denominator. Alright, so this is showing inverse. Now we talked about direct variation is always a straight line. Well, look at this one. Is this a straight line? No. It's not a straight line. Does it go through 0, 0? No. So they are different pictures, but I kind of like these pictures because it's a dead giveaway, whether it's inverse or direct variation. Okay, let's see what's next. Again, I don't think it's in your workbook, so just, oh, perfect. This one we have to say, after we solve for y, whether it's direct variation, inverse variation, or neither. Just watch. Right here, we're solving for y. What's going on with this 5 and the y right there? They're multiplying. Right now they're multiplying, right? How do you get rid of a multiply? Okay, be careful with this. Just watch, guys, just watch. So divide by 5. Our final answer would be y equals x divided by 5. Are you okay if I write it like that? Okay, you with us still? Pause. Is this direct variation?
No.
Why not? It's not a fraction, it's division. Now be very careful, because division is always the inverse, right? Inverse variation, however, is our x in the right spot. It always has to be where? This is totally in the wrong spot. So this is not inverse variation because x would have to be at the bottom. So this would just be plain old neither. Yeah? Okay, hold on. Next part, guys, what's going on with the 1/3 and the y?
They're multiplying.
I'm hearing multiplying and dividing. Which one is it?
Multiplying.
Okay, they're totally multiplying. They're next to each other. How do you get rid of it?
Division.
Okay, divide by 1/3 on both sides, because I'm going to rewrite this and remind you of previous skills. So we've got y equals, I'm just going to write this as a fraction, 1 over x. I'm going to put my divide sign and leave this as a fraction, 1/3. This is a great review. We divided by fractions like months ago. Now when we divided fractions, I taught you keep, change, change. Do you remember what that means? Keep this, change this to what? Yes! And then change the other one to what? Flip it around. You have it. Flip it around. Keep, change, change. Weird. My board's being silly. Okay. Now we can just do top times top, bottom times bottom. You ready? Guys, what's 1 times 3? Okay, be careful. I heard weird stuff this morning. What's x times 1? Just plain old x, right? Okay, look at this one. Is this showing multiplication or division? Division. Which one matches division? Inverse. Inverse variation matches division. But then you got to make sure the second check is x in the right spot. It is. So this one we would say inverse. Because way to hang in there. Good job. Okay, last one of this type. Okay, we're solving for which variable always?
Y.
Solve for y. Solve for y. What's bugging y right now?
7.
How do you get rid of it plus 7?
Minus 7.
Minus 7. So we've got y on this side alone. That's what we wanted. Equal sign. Be careful. Are these like terms? No. So let's just write it like this. Okay. Is this showing multiplication? Is it showing division?
No.
So what are we going to put?
Neither.
Totally neither. Good job. Okay. Next part is in your workbook. So open them up. Close them. We're on. Oh, I forgot about this one, but get ready. We are almost to this one. Okay, this one right here, look. I wanted to put this one in the notes in case you get lost and you can't find the equation. Sometimes they're in the picture. So our equation is y equals 8x. 8 over x, excuse me. What is going on is we're pretending we're painting our classroom. We can paint the walls, that'd be nice. So we're going to paint the classroom. If it's just me painting, is it going to take forever?
Yeah.
So right here it's saying one worker, me, going to take over 7 hours. Yikes. But if I get Jake to help me, is it going to take less time?
Yeah.
If it's Jake and Ethan and me, is it going to take less time? Less time, less time. Look at this picture. Is this picture showing direct or inverse? Totally inverse variation, right? Okay, so letter C, all it's saying is use the equation, which is y equals 8 divided by x, to find what happens when x equals 5. When we have 5 workers, how long will it take us? So all you have to do, watch, it's like the nicest story problem ever. So do y equals 8, replace that x with a 5, grab your calculator, just do it. What does that line mean? Divide. 8 divided by 5. Max of 1.6, is somebody backing up?
Yes.
1.6 hours? Not too bad. Thumbs up, how many are like, that wasn't too bad of a story problem? Yeah? Okay, here we go. Sorry, I jumped the gun. Now we're in your workbook. 84, open it up. I like these ones. Guys, we get to make tables. Tables are so organized, and I like being organized. Okay, so our pretend problem is we're having a party, and there are going to be 200 cookies at this party. We just got to figure out how many people are going to be there. So it says 200 cookies definitely there. Let n represent the number of people. Okay, let's put n equals people. All right. And C represents cookies. Yum. And let's make a table. I'm going to make a table this way so I have room. Feel free to do the same. And then let's get four columns in there. Okay, so we've got 200 cookies. That's already set, right? Well, maybe it's your party and sorry, everybody already left for Thanksgiving, so nobody can come to your party. It's just you. So how many cookies could you eat? Yuck, please don't eat all 200, but technically you could. All right, so you're like, man, I forgot everybody's leaving town, and your mom feels bad that you're feeling bad, so your mom's like, I'll come to your party. Now there's you and your mom. All right, so we've got 2 people at your party. Between you and your mom, how many cookies can you have? Perfect. All right, and then someone comes to deliver something to your house, and you're like, you know what, join my party for a little bit and eat some cookies. Maybe we shouldn't do 3. Let's do 4. Let's say the mailman and the FedEx guy, you're like, have some cookies, please. We have too many cookies. So now there's 4 of you. How many cookies can you each have? 50 or 25, which is it?
25.
I agree with the 50. All right, you're desperate to join. Let the dog join. All right, the dog sneaks some cookies. Don't let your dogs eat cookies, but just in case he did, we'll count him as a 5th person because he's in your family album. So if there's 5, how many cookies can you each have? 25. Okay. All right. Here we go. Question for you. Using n for people, C for cookies, we now have to write an equation. So we've got to use the n, we've got to use the c, you've got to think, what were you doing in your calculator every single time? I always go with the last one. How did you go from 5 people to 25 cookies? Where did that come from? I want a hand in the air. Thinking, what did you do? 200 divided by n equals c. Okay, once you think of something, then test it. So 200 divided by 5, did that really equal 25 cookies?
No, it's 40.
40? Do we need to fix this 25? Is it 40? That makes more sense. Good thing Dagan came up with our equation we can check. Okay, grab your calculators, type it in. 200 divided by 5, is that 40 cookies?
Yes.
All right, check this one. What's 200 divided by 4?
I know.
50. 200 divided by 2? Did Dagan get the equation? He did. That's perfect. Get it in your workbooks. You need a table and an equation. Again, get it in your workbooks, the table and an equation. Okay. Next one. We're going to pretend that you guys are restaurant workers. So let's see, it says R represents our hourly rate. So let's put R equals money per hour. And P equals total money. Total money. All right, same thing. Let's make a little table for ourselves, nice and organized. Let's do the same thing. Let's do 4. 1, 2, 3, 4. Okay, let's pretend that you guys start as waiters or waitresses. They don't make very much money because they rely on tips. So the restaurant only has to pay you like $2 an hour. And the rest is pure tips. You gotta be good. You gotta remember that people like Dr. Pepper or whatever. But you're working 20-hour weeks. So if you make $2 an hour and you work 20 hours, how much money do you take home at the end of the week? Perfect. Put it in your table. Good job. Yeah, that's not so great, right? Hopefully you get lots of tips. Okay, what if you're like, I hate being a waiter or a waitress. People are mean and grumpy. So you're like, all right, I'll be a host or a hostess. They make a little bit more. Let's say $7. $7 an hour. $7 an hour, but you still work 20 hours a week. I want a hand in there. How much are you taking home as a host? Cooper. 140. Better, right? Okay. And then you're like, yeah, I kind of don't want to deal with people. I'd rather deal with food. So maybe you're like, I'm going to try being a chef. So now you're in the kitchen and you don't have to deal with grumpy people. Let's say as a chef, you're making $15 an hour. $15 an hour, 20 hours a week. Courtney, how much are you making as a chef? 300? Okay. Maybe you're like, man, this still isn't enough. I'm gonna buy this restaurant and pay myself. So you are now the owner of the restaurant, the manager, and you're gonna pay yourself $50 an hour? Alright. $50 an hour, but you're still only working 20 hours a week. How much are you taking home, Sarah? $1,000 a week. That is a lot of money. Okay, table. Are we done once we're done with the table? No. We need an equation. Thanks, Jogan. So we need to use R, and we need to use, so that's dollars per hour. We need to use P, the total, and we probably need to use this 20 hours. Somebody try the equation? How to use R, P, and the 20. Dave, want to try again? Go ahead. 20 divided by R equals P. All right, grab it. Here we go. Type in 20 in your calculators. Dagan said to divide it by R. 20 divided by 2, do we get 40? Uh-oh. Let's adjust it. Let's adjust it. Alex, what do you want to adjust it to? Okay, you know what? You said R times 20. Are you okay if I just do 20R? Same thing, right? Ooh, let's try it. You think? 20R, 20 times this will give us this. 20 times this will give us. Alec, good job. Box it. I'm impressed. Good job, good job. Whew. Okay, one more. It's so appropriate because a lot of us are probably traveling for Thanksgiving, right?
I'm not.
No. I know. Last table, are you ready? Reading the directions, it says 240 miles trip. Y'all kind of get car sick. Let T represent the number of hours. Okay, so let's put T equals hours. And it says S represent the speed of the car. S equals speed. Yeah. Let's do the same table. Let's just do 5 total columns. 1, 2, 3. That'll be good. Okay. So on this one, hours. We go, no matter what, to our cousin's house. It's 240 miles. So what if it takes us 2 hours? 2 hours. If it takes you 2 hours to go 240 miles, how fast are you going? Figure it out. How fast? Yikes, 120 miles per hour. Danger. All right. Let's do 3. Let's try 3. What if it takes you 3 hours to go 240 miles? How fast are you going? 80? 80 miles per hour? It's a little bit safe. Well, it's safer, but it's still kind of dangerous. All right, let's say 4 hours. What if it takes you 4 hours? How fast are you going? 60? Really? All right, 60 miles per hour. That's pretty regular. All right, you want to try 5 hours?
Yeah.
If you're taking your time, 5 hours to go 240. 48 or 30? 38? Stop. I'm getting confused. I'm hearing 48 and 38. Can only be one of them.
48.
Are you sure? Okay. 48 miles per hour. Are we done now that we're done with the table? No, we need an equation. The equation has to use everything they gave us. T, S, and 240. How are we going to put those all together into an equation? It's in there already. Max, what do you think? 240. So the miles divided by the time will give us the speed?
Yes.
All right, 240 divided by 2, is that 120?
Yeah.
240 divided by 3, is that it?
Yes.
How many feel good about Max's equation? Yeah? I got that. Okay. Open your workbooks to page 86. I'm going to help you. Are you okay with that?
Yes.
Okay. Open to page 86. Okay. This one, no pictures, unfortunately. I love pictures. Now we have to decide, is this direct variation, inverse variation, or neither? First, we always have to solve for y. What do we always solve for? Y. Okay, so follow along with me. Right here, the only thing right now that's bugging y is the 2. What's going on with the 2 and the y right now without doing anything? How do you get rid of multiplying? Okay,
So I'm just gonna write my divide sign. Divide by 2. Over here, divide by 2. Make sure you get this in your workbooks. I want to see all of this. So then we've got y equals 3x plus 1 divided by 2. Okay. Only one of these, direct variation or inverse variation, has divide in it. I want a hand in there. Do you remember which one has divide in it? Hand in there, hand in there. Charles, which one? Inverse. Inverse variation has divide, but there's another trick with inverse. Has to be division, but something else has to happen. Do you remember, Oakley? Variable has to be right here. Is the variable right there?
No.
So what are we going to put? Direct, inverse, or neither?
Neither.
Thanks, Oakley. Again, I want to see absolutely all of this in your workbooks. Not just neither. I need to see the work to back it up. Alright, number 2. Same thing. We're always solving for y. Well, right now the 5's bugging it. But what does this line right here mean? How do you get rid of it? Okay, let's times this by 5. So let's times this by 5. Alright, I'm going to write it like this. So y equals 6 divided by x. I'm just going to write times by 5 out here so I have more room. Well, we've got a fraction times a whole number. I like doing fractions times fractions because then I can just do top times top, bottom times bottom. So how do you make the 5 a fraction? Yeah, perfect. Sneak a 1 in there, guys. Again, stay with me, stay with me. Alright, top times top, we'll have y equals numerator 6 times 5.
30.
Denominator x times 1.
X.
Let's say x. Anything times 1 is itself, right? Okay, only one of those talks about division. Which one is it, guys? Inverse, but pause. You gotta do the second check. Is the variable in the right place?
Yes.
Yay! So this one, we can't really see that. Inverse. Okay, next ones I'm going to help you with, number 5 and number 6. This one you have to write an equation from a graph, dun dun dun. But it says it has inverse variation. Inverse variation always looks like this. Y equals something over x. You have to figure out the something. Number 6, y equals something over x. You have to figure out the something. Okay, are you ready for some hints? Okay, right here they give you a hint in this first picture. This is your hint. 1, 5. The 1 is either an x or a y. Do you know which one it is? It is totally an x. It's the x-axis. So this is an x. This is a y. So, if you plug those into your equation, you can figure out the missing piece. So for the y, let's put 5. And the x is 1. So you have to figure out what number can go here. What divided by 1 will give you 5? That's it. That's how you figure those ones out. Not too bad, right? Yeah, but not always. Be careful. Like number 6. Maybe we say that's the second number. I think that just worked out conveniently. Watch on number 6. Number 6, let's do the same thing. So number 6, is the 2 an x or a y? X, and this is a y. So if we're sticking it in, we'd have 3.5 equals something, and x goes on bottom. So you got to figure out what divided by 2 will give you 3.5. What kind of guess what? That's it. But again, I want to see all that work on there. Not just these answers. I want to see this to back it up. Okay, number 7.